Tēnā koutou. Welcome to this video lesson on calculating probabilities with the normal distribution. Now, in our previous lessons, we talked about using a z-score to calculate probabilities for my standardized normal distribution. The thing is, when we collect data in the real world, it's not going to fit into that standard normal distribution. So you need to standardize it, meaning you want to take your normal distribution and do some changes so that the mean becomes 0 and the size of each standard deviation becomes 1. Now, the way we do that, we're going to convert a x measurement, which is going to be put into a distance from the mean, which is mu. So x is going to become x minus mu, and we want to know how many standard deviations fit into that space. So we're going to divide by sigma, which is the standard deviation. Here's what you want to remember, that whatever your x value is, subtract the mean, get the equals, and then divide by sigma to change it into a standard normal. In other words, this is going to be a measure of how many standard deviations we are from the mean. And once we've got it into a standard normal, then the z-score can be used. So this is what you want to put into your notes. The z value will be x value minus mu equals, and then divide that by the standard deviation. That is going to change your x score into a z, which you can then use the z table we talked about in our last video lesson. So have this into your notes, okay? To calculate a z score, you need to know three values. The x value, which is the value you're being standardized. So in other words, if I went back to this example here, if I wanted to change this score of 870 into something along a standard deviation, I need the x value, which is going to be the value found along the horizontal axis. You're going to need to know what the standard deviation is for that particular problem, and also the mean mu. Once you've got those three values, they go into that equation, and that's going to again change an x value into a z score. So the z value is going to be positive when the x you're choosing is above the mean, and your z value is going to be negative if you're choosing a value that is below the mean. Okay, example. The weight of a newborn puppy is normally distributed. You draw that curve. Newborn puppies have an average weight of 850 grams with a standard deviation of 20. Now, they didn't tell you that the 850 was the mean, but when you see that, when they tell you that's the average, that means the 850 is the mean. Calculate a z-score of a puppy weighing 890. Well, since 890 is bigger than 850, we know that z value has to come out to be positive. So we've got 850 is the mean, sigma or the standard deviation is 20, and we want to convert that 890. So it's x minus the mean divided by 20. 890 minus 850 gives us 40, divided by 20 is 2. So we know that a z-score of 890 would translate into being 2 standard deviations above the mean. All right? So there's one example done. We're going to have some we're going to try in class. Let's see how much of this one we can get done before we run out of time. A distribution x has a mean of 25. That's right there. Standard deviation of 4. Calculate the probability x greater than 30. So if the mean is 25, that means right there is our 25. Okay? Standard deviation of 4. So that means that the sigma is 4. We want to calculate x greater than 30. Well, that 30 needs to get changed into a z-score. So 30 minus 25 is 5. 5 over 4 is 1.25. You would look up 1.25 in the table, and that would be how we're going to find that problem. We're going to save that one for class next time, but go back to have a look at the video on using a z-score if you need. Thanks for watching. We'll be right back with part 2 of this video.